Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Lu Min from Huadong Power. Today, we will study Chapter 1, Electrical Control of Automatic Punching Equipment, Stepper Motor Power Supply Circuit. We will explore this topic from the following parts. 1. Basic composition of the power supply circuit. First is the power supply module. Common power supply modules have a wide range of output voltages, including commonly used DC voltages, such as 5 volts, 12 volts, and 24 volts, as well as higher AC voltages ranging from 36 volts to 70 volts, or DC voltages from 8.2 volts to 45 volts. Next is the controller. It can generate pulse signals, STEP, and direction signals, DIR, which are used to precisely control the stepping angle and speed of the motor. There are many types of commonly used controllers today. For example, microcontrollers include Arduino and STM32, and there are also dedicated driver chips like AHU4988 and DRV8825. The third key component is the drive module. The primary function of the drive module is to convert the control signals from the controller into the power output required by the motor. It typically includes power amplifiers, such as H-bridge circuits, and drive chips like TD6560 and TMC2208. In high-power applications, to improve efficiency, MOSFETs or IGBTs are often used for power amplification to meet the motor's power requirements. Then there is an optional component, the feedback system. It monitors the motor's operating status through position sensors or current sensors, enabling closed-loop control. This can effectively prevent issues such as missteps in the stepper motor during operation, thereby enhancing the accuracy and stability of control. The last important part is the protection circuit. It provides various protective functions for the entire system, such as overcurrent, overvoltage, and overtemperature protection. Common protective components include fuses, current limiting resistors, and temperature sensors. 2. Criteria for power supply selection. Next, let's delve into the specific criteria for selecting a power supply. First, we need to choose the type of power supply. Common types include switch-mode power supplies, linear power supplies, and batteries. Switch-mode power supplies are characterized by their high efficiency and small size, making them suitable for most applications. Linear power supplies, on the other hand, produce less electromagnetic interference and are better suited for precision applications where accuracy is critical. Batteries are primarily used in portable devices. For AC power supplies, they can provide higher torque, but require a voltage stabilizer to ensure stable voltage output. DC power supplies, meanwhile, need to focus on suppressing ripple to ensure good power quality. Next, we need to consider the voltage and current requirements. When selecting the voltage, we must balance performance and heat generation. For low-speed motor operation, a lower voltage, such as 24 volts, may be sufficient. However, if the motor needs to operate at high speeds to enhance torque, a higher voltage is necessary. Regarding current requirements, the power supply capacity should be slightly higher than the motor's maximum demand. For example, if a motor requires a maximum current of 3 amperes, it is advisable to pair it with a 4 ampere power supply. Lastly, stability and protection features are crucial. A high-quality power supply must have protection against short circuits, overloads, and overtemperature conditions. To minimize output ripple, it is recommended to use low equivalent series resistance, ESR, electrolytic capacitors for filtering. 3. Design methods for drive circuits. Next, let's discuss the design methods for drive circuits. First is the selection of the drive chip. We need to choose the right drive chip based on the parameters of the stepper motor. For example, The DRV8825 drive chip is well suited for bipolar motors, while the TV6560 can support high current drives, achieving a drive current of up to 4 amperes. Additionally, micro-stepping technology is an important factor. Micro-stepping techniques, such as 1/16 stepping, can significantly improve the smoothness of motor movement, but also demand higher precision in current control. Next is the power amplification design. For bipolar drives, an H-bridge circuit is typically used, while for unipolar drives, Darlington transistors, such as the ULN2003, are commonly employed. When designing the power amplification circuit, it is important to provide suitable heat sinks for the power transistors. To enhance the stability of the power amplification circuit, temperature compensation components should also be used. The last topic is interference immunity measures. To reduce electromagnetic interference, we usually employ opto-isolation circuits to separate the control signals from the power circuit. In terms of circuit layout, filtering capacitors, such as a 100 microfarad electrolytic capacitor and a 220 picofarad ceramic capacitor, should be placed as close as possible to the pins of the drive chip. Lastly, please complete the exercises after class. I hope you can gain a comprehensive and in-depth understanding of the stepper motor power supply circuit and master the relevant knowledge and skills. That's all for this lesson. Thank you for your attention. See you in the next class.